This is an audio-visual presentation on sequence and series. Sequence refers to the order in which one or more things, example, number or terms, follow each other. Now, this is an example of a sequence. We have 1, 3, 5, 7, etc. The first term is 1. The second term of the sequence is 3. The third term is 5, and the fourth term is 7. So this is an example of a sequence. Now, when the terms of the sequence are added, we have what we call the series. Now, when we consider the sequence 1, 3, 5, and 7, when we add the terms together, that is 1 plus 3 plus 5 plus 7. In that order, we have what we call the series. So when we add the terms of the sequence together, we have what we call the series. Now, we consider the types of sequence. We have the arithmetic progression, that is the AP. And this type is also known as the linear sequence. We also have the geometric progression, that is the GP, also known as the exponential sequence. So the arithmetic progression is known as the linear sequence, and the geometric progression is known as the exponential sequence. Now, we first consider the arithmetic progression, that is the linear sequence. This is a sequence with the same common difference. Now, let's consider the sequence 2, 4, 6, and 8. The first term of the sequence is 2, and so the first term A is equal to 2. The first term is represented by the letter A, so the first term of the sequence given is 2. And the common difference is also represented by the letter D. Now, how do we find the common difference? When you look at the sequence given, we have 2, 4, 6, and 8. We can see that the difference is 2, because when we add 2 to 2, we have the second term, that is 4. When we add 2 to 4, we have the third term, that is 6. And when we add 2 to 6, we have the fourth term, that is 8. So we can see that the common difference is 2 throughout. Now, how do we find the common difference? The common difference, D, is equal to 4 minus 2, or 6 minus 4, which is the same as 8 minus 6, and the answer is 2. That is how come we have 2 as our common difference. This means that the common difference is the second term minus the first term, or the third term minus the second term, or the fourth term minus the third term, and this will give you the same answer 2. That is how we find the common difference. Now, let's consider the nth term of an AP, that is the linear sequence. The nth term of an AP, that is a linear sequence, is given by U subscript n is equal to A plus n minus 1D, where A is the first term of the sequence, n is the number of terms of the sequence, and D is the common difference. So the nth term of a linear sequence is given by Un equals A plus n minus 1D. Take note that the n is a subscript to U. So it's U subscript n equals A plus n minus 1D. The A is the first term, n is the number of terms, and D is the common difference of the linear sequence. Now let's look at this example. What is the 15th term of the sequence 3, 7, and 11? Now, this is the linear sequence we are given. It's a linear sequence because it has the same common difference, and you can see that when you look at the sequence, the common difference is 4, because when we add 4 to 3, we have 7. When we add 4 to 7, we have 11, in that order. So this is an example of a linear sequence. Now, from this question, we are told to find the 15th term of the sequence. The 15th term of the sequence. We are only given the first 3 terms, and we have to find the 15th term of the sequence. Now let's look at how best we can solve this problem. Now solution. From the question, we were given the sequence 3, 7, 11. Take note that the terms of a sequence are separated by the comma. So we have 3, 7, and 11. Now when we look at this sequence, the first term of the sequence is 3. That is why A is equal to 3. And from the question, we have to find the 15th term. And so N is equal to 15. Now D is the common difference. And the common difference is equal to 7 minus 3. That is the second term minus the first term. Or it can be your third term minus the second term. You will still get the answer 4. So the common difference is equal to 7 minus 3. And 7 minus 3 is equal to 4. Now we know from the relation that the nth term of a linear sequence is given by un equals a plus n minus 1d, where the a is the first term, n is the number of terms, and d is the common difference. Now by substitution, we have 3 plus 15 minus 1 times 4. Why do we have 3? Because the first term a is equal to 3. N is the number of terms, that is 15 from the question, and D is the common difference, that is 4 from our calculation. Now we have 3 plus 15 minus 1 times 4, and 15 minus 1 equals 14. 14 times 4 will give us 56. So we have 56 plus the first term, that is 3, and 3 plus 56 is equal to 59. This means that the 15th term of the sequence is 59. Now, let's consider this example. The 5th and 10th terms of a linear sequence are minus 12 and minus 27 respectively. Find the first term and the common difference of the sequence. Now, from the question, we are told that the 5th and the 10th terms of a linear sequence are minus 12 and minus 27 respectively. This means that the 5th term of the linear sequence is minus 12. And the 10th term of the linear sequence is minus 27. That is the meaning of the respectively. It means that the 5th term is minus 12 and the 10th term is minus 27. Now we are asked to find the first term and the common difference of the sequence. Now solution. We know that for a linear sequence, the nth term is given by un equals a plus n minus 1d. Where a is the first term, n is the number of terms, and d is the common difference. Now from the question, we are told that the 5th term is equal to minus 12. That means that when n is equal to 5, the answer is minus 12. And we are also told that when the 10th term, when n is equal to 10, that is the 10th term is equal to minus 27. So when n is equal to 10, the answer is minus 27. When n is equal to 10, we have u10 to be equal to minus 27. And when n is equal to 5, we have u5 to be equal to minus 12. That is from the question. Now, from u5 equals minus 12, it means that n is equal to 5. It means n is equal to 5. So we substitute 5 wherever we see n in the nth term formula. And in doing that, we have u5, that is u subscript 5, equals a plus 5 minus 1d is equal to minus 12, because u5 is equal to minus 12. Now we have a plus 5 minus 1 is 4, and 4 times d is 4d. So we have a plus 4d is equal to minus 12. Let's name this equation 1. Now we also have it that u10 is equal to minus 27. That is the 10th term of the linear sequence equals minus 27. So wherever we see n in the nth term formula, we also substitute 10. And so in doing that, we have u10 equals a plus 10 minus 1 times d. And this is equal to minus 27. Now 10 minus 1 is 9. And 9 times d is 9d. So we have a plus 9d equals minus 27. And this is our equation 2. These are the two equations that we are going to solve for the values of a and d, where the a is the first term and the d is the common difference of the linear sequence. Now solving the two equations simultaneously, we have a plus 4d equals minus 12. That is our equation 1. and we have a plus 9d equals minus 27. This is our equation 2. Now these are the two equations. Now we use the elimination method in solving this problem. So we eliminate a. We are going to eliminate the variable a. Now we can see that the variable a has the same constant coefficient, that is 1. The coefficient of a in equation 1 is 1, and the coefficient of a in equation 2 is also 1, and they have the same sign, so we subtract one equation from the other. Now subtracting equation 1 from equation 2, we have a minus a, that is a minus a, plus 9d minus 4d. So we subtract 4d from 9d. That is how come we have 9d minus 4d. It means that we are subtracting 4d from 9d. And this is equal to minus 27 minus minus 12. That is, we are subtracting minus 12 from minus 27. And this is how it's written. Minus 27 minus minus 12. Now a minus a equals 0. 9d minus 4d equals 5d. And 0 plus 5d is equal to 5d. So 5d on the left hand side is equal to minus 27 plus 12. Because minus 1 times minus 12 will give us plus 12. Take note that the coefficient of the bracket is 1. And so minus 1 times minus 2 minus 12 is equal to plus 12. Minus 1 times minus 12 equals plus 12. Now minus 27 plus 12 is equal to minus 15. And so we have 5d on the left hand side is equal to minus 15 on the right hand side. Because we are solving for the common difference, we divide both sides by 5. So dividing 5d by 5, we are left with d. And dividing minus 15 by 5, we have minus 15 divided by 5. And the answer is minus 3. Because 5 goes into 15 3 times. But because of the minus, that is why we have minus 3. This means that the common difference is equal to minus 3. Now putting d equals minus 3 into equation 1. That means that wherever we see d in equation 1, we substitute minus 3. From equation 1, we have a plus 4d equals minus 12. And now d is equal to minus 3. So by substitution, we have a plus 4 times minus 3 is equal to minus 12. Now when we multiply 4 by minus 3, the answer is minus 12. And that is how come we have minus 12 in the bracket. Now to open the bracket, we have a minus 12 is equal to minus 12. Because we are making a the subject, minus 12 on the left hand side becomes plus 12 on the right hand side. And so minus 12 plus 12 will give us 0. This means that the first term of the linear sequence is equal to 0. And the common difference is equal to minus 3. Now we look at the sum of the n terms of an arithmetic progression. And the sum of the n terms of an AP, or the arithmetic progression, or the linear sequence, is given by Sn, that is S subscript n is equal to n over 2 into bracket 2a plus n minus 1d, where n is the number of terms, a is the first term, and d is the common difference. So that is the terms that we have defined. A is the first term, n is the number of terms, and d is the common difference. This is the relation we are going to use in finding the sum of the n terms of an arithmetic progression or the linear sequence. Now, when the last term of the sequence is known, we can use the formula Sn equals n over 2a plus l to calculate for the sum. We can only use this formula when the last term of the sequence is known. That is, when the sequence is a finite sequence. Then we can use the relation Sn equals n over 2 into bracket a plus l, where n is the number of terms. N is the number of terms. A equals the first term, that is a is the first term, and l is the last term, so our l is the last term. So when the last term is known, we use the formula Sn equals n over 2 into bracket a plus l. Now let's look at this problem. Find the sum of the 10 terms of the sequence, and the sequence is 3, 6, 9, and 12. We can see that the first term of the sequence is 3. and the common difference is 3, because when we add 3 to 3, we have 6. That's the second term. When we add 3 to the second term, we have the third term, that is 9. When we add 3 to the third term, we have the fourth term, that is 12. So considering this sequence is a linear sequence, and we are asked to find the sum of the 10 terms. That means that n is equal to 10. Now let's look at the solution to this problem. From the question, we were given the sequence 3, 6, 9, and 12. We know that the first term is equal to 3, which we can see. The common difference is 6 minus 3. That is the second term minus the first term. The common difference equals 6 minus 3. That is the second term minus the first term. The second term minus the first term, or the third term minus the second term, or the fourth term minus the third term. And at the end of the day, you get the same answer. So our common difference is equal to 6 minus 3. That is the second term minus the first term. And 6 minus 3 is equal to 3. Now from the question, we have to find the sum of the 10 terms. That means that n is equal to 10. Now we are going to substitute a equals 3, d equals 3, and n equals 10 into the formula. Sn equals n over 2, 2a plus n minus 1d. Now n is equal to 10. So we have 10 over 2. Instead of n over 2, we have 10 over 2 because n is equal to 10. Now 2 times a. Now we know that a equals 3. So we have 2 times 3 plus n minus 1. Because n is equal to 10, we have 10 minus 1 times d. And d from our calculation we have 3. So we have times 3. Now 10 divided by 2 is equal to 5. 2 times 3 is equal to 6. Plus 10 minus 1 is 9. And so we have 9 times 3. Now when we multiply 9 by 3, the result is 27. So we have 27 plus 6 in brackets times 5. And 6 plus 27 is equal to 33. 33 times 5 is equal to 165. This means that the sum of the 10 terms of the sequence 3, 6, 9, and 12 is 165. That is the sum of the 10 terms. Now, let's consider this example. Find the sum of the numbers 2, 4, 6, 8, and 10. The first term is 2, and the last term is 10. Now, we know the last term. And so we use the formula Sn equals n over 2 into bracket a plus l. We know that n is the number of terms, a is the first term, and l is the last term. Now n is the number of terms. When we count the number of terms, we have 1, 2, 3, 4, 5. And that is why n is equal to 5. The first term a is equal to 2. That is the first term of the sequence. And l is equal to the last term, that is 10. So the last term equals 10. Now from the formula Sn equals n over 2a plus l. By substitution, we have S5 equals 5 over 2 into bracket 2 plus 10, where 2 is the first term a, and 10 is the last term, that is l, and n is the number of terms, that is 5 from the problem. So we have 5 over 2 into bracket 2 plus 10. Now 2 plus 10 is equal to 12. So we have 12 times 5 over 2. Now 2 goes into 12 6 times, and that is how come we have 6 in the bracket. Don't forget you have 5 outside. So 5 times 6 will give us 30. So the sum of the terms 2, 4, 6, 8, 10, according to the formula, has now given us 30. Now let's take note of this. When we say sum, it means that we are supposed to add the terms. So let's add the terms 2 plus 4 plus 6 plus 8 plus 10 and see what we are getting. Now 2 plus 4 is 6, and 6 plus 6 is 12. 12 plus 8 is 20, and 20 plus 10 is 30. So we can see that we are getting the same answer. That is the meaning of what we are doing. So the sum is equal to 30. Now we look at the geometric progression. or the GP, also known as the exponential sequence. This is a sequence with the same common ratio. This is the sequence with the same common ratio, R. Now when we consider the sequence 2, 4, 8, 16, the first term is 2. The difference between the first term and the second term is 2. The difference between the second term and the third term is 4. The difference between the third term and the fourth term is 8. So we can see that the difference is not the same, and therefore it is not a linear sequence or an arithmetic progression, but rather a geometric progression. So for a geometric progression, it has the same common ratio. Now, considering the sequence 2, 4, 8, 16, the first term A equals 2. How do we find the common ratio? The common ratio is equal to 4 divided by 2, which is equal to 8 divided by 4, which is equal to 16 divided by 8, and the answer is 2. What are you doing here? To find the common ratio is given by the second term divided by the first term. That is 4 divided by 2. Or the third term divided by the second term. That is 8 divided by 4. Or the fourth term divided by the third term. That is 16 divided by 8. And in all these three cases, the answer is 2. That is how we find the common ratio. Now, let's look at the nth term of a GP. The nth term of a geometric progression, also known as the exponential sequence, is given by un, that is u subscript n, is equal to ar exponent n minus 1, where a is the first term, r equals the common ratio, and n is the number of terms. Now let's look at this example. Find the sixth term of the sequence. Find the sixth term of the sequence. That means that we have to find the sixth term of the sequence. So n is equal to 6. Now the sequence given is 2, 6, and 18. From the question, we are not told whether the sequence is a linear sequence or an exponential sequence. Now, when we look at the difference between the first term and the second term, the difference is 4. When we look at the difference between the second term and the third term, the difference is 12. That means that the common difference are not the same, and therefore it is not a linear sequence. Now, let's check the common ratio and see. How do we find the common ratio? It is the second term divided by the first term, and so 6 divided by 2, the answer is 3. Or the third term divided by the second term, so 18 divided by 6, the answer is 3. So we can see that it has the same common ratio, and therefore it's an exponential sequence. So the first thing you have to do is to identify whether it's a linear sequence or an exponential sequence before you can use any formula. Now let's look at the solution. From the question, we were given the sequence 2, 6, and 18. So the first term A is equal to 2, and the common ratio is 6 divided by 2. That is the second term divided by the first term. 6 divided by 2 is equal to 3. Now, from the question, we have to find the sixth term. That means that n is equal to 6. So by substitution, u6 equals 2 times 3 exponent 6 minus 1. Because the nth term is given by ar exponent n r minus 1. ar exponent n minus 1. That's the nth term of a geometric progression, where the a is the first term, r is the common ratio, and n is the number of terms. So by substitution, we have 2 times 3 exponent 6 minus 1, where 2 is the first term, a. 3 is the common ratio, that is 3. R equals 3, that's the common ratio, and n equals 6, that's the number of terms. Now 6 minus 1 equals 5. So we have 2 times 3 exponent 5. Now, Make sure you don't multiply 2 by 3 before you raise it to an exponent 5. Because of the exponent of the number 3, you cannot multiply 2 by 3. Now 3 raised to the power 5 is equal to 243. Now after simplifying 3 raised to the power 5 to get 243, you can now multiply 243 by 2, and the answer is 486. That means that the sixth term of this sequence is equal to 486. Is equal to 486. Now example, find the seventh term of the sequence 3, 9, 27. Find the seventh term of the sequence. Now we can see that this is an exponential sequence because it has the same common ratio. How do we find the common ratio? The second term divided by the first term. And when we divide 9 by 3, the answer is 3. Or the third term divided by the second term. When we divide 27 by 9, the answer is also 3. So it has the same common ratio. That means that this sequence is an exponential sequence. So you are supposed to use the nth term of an exponential sequence to find the seventh term. And after calculation, you are supposed to get 2187. 2187. Now take this as an exercise and find the seventh term of the sequence 3, 9, 27 and see whether you get the answer 2187. This is the end of our presentation on sequence and series.